Hi guys.
Thanks, Priya.
Yeah,
Could you add me to the WhatsApp group chat? Because I don't know why I can't, like, I'm trying to add myself, but I can't because I've been removed or something.
I am so sorry. See, wait, ma, let me see. Wait, let me check. I'll right away add Madhvani.
Yeah, because I had to call my mom and ask if there's
Sorry,
something
ma.
to
Your
group
mom
chat.
is there in the group, huh?
Yeah.
Sorry, ma. Are you there? Can you check, please?
Uh,
What happened
yeah.
to Parvini? Let me quickly check, ma. What happened to Parvini? What happened to Manav? Oh my gosh. It's very hard to get this class up and going. Let's see. Parvini is not in here. Who else is not in here? Oh my God. Sri Charan won't come in this class, right? But I don't see. That's it, right? Okay, let's go ahead. Hey, thank you guys. Sorry, I see my phone is as well not even on. So sorry. I had to message when I was outside and I had to delay the class by 20 minutes. Very sorry, guys. Okay, what are they discussing in school, Krish?
We're doing limits and continuity, and then today we had a concept check over limits, and then the four types of like techniques to solve those limits.
Oh, graphically, analytically, like that, huh?
Yeah, like the canceling method, the
Yeah,
factoring
yeah, yeah, yeah,
method.
yeah, yeah.
Yeah,
That we learned, right?
yeah,
Was it easy?
yeah.
Is it making it easier for you, Krish?
It's easy. Yeah,
Okay, that's nice.
it's helping.
Okay, okay. Okay. Also, let me know, is there something that they're teaching extra?
Today I didn't have a concept check because I don't know why teachers didn't do concept checks today for us. But we learned the IVT theorem, the independent so, wait,
No,
let
no,
me
no, intermediate value theory. That I did cover,
intermediate.
ma. That is done during summer, ma.
Oh yeah. So that's what we did.
Yeah, that's nice. Intermediate value theorem is very good. So we'll do one or two problems here. Okay. So can I go ahead? Mano was there in this class, right? What happened to him? Yeah, he has to come in this class, right? Yeah. Okay, let's go ahead. Yeah, Mano is here. Okay, so for today, this is test prep. Okay, let's see. Okay, guys. So, for today, right, I want to cover where did we leave off? We did different. We are yet to do differentiability. Manav, what are you doing in school, Manav?
We're doing properties of limits, continuity.
Okay.
Like
Do
all
you?
the
Uh-huh.
plus, like adding limits, multiplying, all that.
Okay. So, was it easy?
Yeah, it was easy. I just have to review it again, and it'll
You
be
just
easy.
have to review it. So it was easy. Not meaning.
Yeah,
I'm thinking that you had ex who you had been exposed to it already. Correct?
the property. I think the properties was new, but it's most of it's the same.
The same. Okay. Okay. So we did discuss differentiability last week, right, guys? The derivative exists for each point in the domain, and after that, what and all should be there. The derivative will fail to exist for a function if there is discontinuity, corner or cusp, or a vertical tangent. We did discuss that last week, right? So let me go ahead and review that once more. Can I share my screen? Okay. 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 When do you say a function is differentiable? We say differentiable if the derivative exists in each point in the domain. Derivative should exist for every point in the domain. Number one. Okay. When do we say differentiable? A function is differentiable. When do you say that? Okay. The first condition is the derivative should exist in every point, for every point in the domain. And then the graph naturally has to be a smooth line. Graph has to be smooth line. Remember last week we showed the sine graph. We did zoom into this, right? When we zoomed in, see, it looked as if it was a straight line, right? So what did we call that as? Remember? It had local linearity. Correct, guys? It looked like if you zoom in, it looked like a line graph. So that's local linearity. When these three conditions are obeyed, then the function is differentiable. Okay. When does the derivative fail to exist? When it has a derivative will fail to exist when derivative fails to exist when number one, when it has a discontinuity. Let's say a graph is like this. See, there is a discontinuity or there is a vertical tangent. Make sense? The last one is corner or a cusp. Corner or cusp, which is an example. Where is the example? This is an example. You see, there's a corner or a cusp. So in these three cases, the derivative will fail to exist. This is just theory. Okay, we'll go ahead and solve some problems so you'll really understand what's going on. Okay. Now, I just want you to tell me, okay, is this true or false? I did discuss this last week, guys, but I'm just reviewing this now. How about this? Which statement is true? Which statement is false? I want to understand, guys. Here we go. Tell me which statement is true, which statement is false. You can guess. Want to guess? Which statement is true, which statement is false?
For this, Miss Priya, could you go back to the last board that you had?
Yes. Last board. Okay. You see it now? Do you see it now?
Just no, I can only see the one that you have on right now, like the one about the true or false.
Oh, last board. Oh my God. This
Yeah.
one? Okay.
Yeah.
Okay.
You can change it.
Can I erase it?
Yeah.
Oh, these will come very handy in a few minutes. Okay. When we start doing the problems, it will come very, very handy. Okay, let's go ahead. Let me erase this. Which is true, which is false, guys? What is a continuous function? What is a differentiable function? We did discuss certain things, right? So what do you think? Which is true, which is false? Differentiability implies continuity. Continuity means what? A function should not have any breaks. What is differentiability? Differentiability fails in three cases. When vertical tangent, the first one was discontinuity, and then the last one was, what did we discuss the last one?
Corner or cusp.
Yes, corner or cusp. So what do you think now? Continuous function means this one. Continuous function means this one. Continuous function is this one, right? These are all continuous functions. Think about whether these are differentiable. This is differentiable. Is this differentiable?
No.
No. Is this differentiable?
No.
No. So what can you conclude? Differentiability implies continuity. Is that correct? When I say function is differentiable, is it continuous?
Yeah.
Yeah, true. When I say continuous, is it differentiable?
No, not always.
Yeah, not always. These two are perfect counter examples. False. Make sense, guys? If you didn't get it, please ask us. We really want to be sure. Arush, you're back home?
No, I'm at a hotel.
Oh, okay, nice. Hey, Arush, by the way, all the very best. Tomorrow morning you're taking the SAT?
Yeah,
All the very best.
thanks.
Let me know how it goes.
Yeah.
Okay, we'll go ahead. Okay. What did I want to do? Yeah, I want to continue. Okay. Last week we were discussing the mean value theorem, right, guys? So what did the mean value theorem say? Let's go ahead and write it down. Mean value theorem. I will draw a diagram as well for that. I will write what it says as well, and we'll see. Okay, we'll see this is intermediate value theorem we already did. Okay, this is called mean value theorem. Okay, so let's if a function f is differentiable, we are considering a differentiable function. Okay, a differentiable function means it's also a continuous function. Okay, over the interval a comma b, right? Let's consider this function. I want to. So let's consider this function. Okay. Now let's consider interval a comma b. This is b, this is a, right? Over the interval a comma b. So what are we considering? Only this piece. It is differentiable and continuous, right? There exists a point within that open interval. Within that open interval, a and b is not included. So within that open interval, there exists a point where the instantaneous rate of change is equal to the average rate of change. So what is the average rate of change between these 2 points? F of b minus f of a divided by b minus a is your average rate of change. Any questions here? So between these two intervals, there will exist a point where the instantaneous, meaning there will be some point. Okay, if I draw a tangent here, no, tangent slope is not the same as the black line slope. If the slope needs to be the same, right? How should that be? If the slope needs to be the same, then whatever line I draw, meaning I can draw a tangent here, I can draw a tangent here, right? It becomes like this. It becomes like this. They don't seem to be parallel at all. I can draw a tangent here. These are not the points they are thinking, okay? But think about this point. Let me draw a parallel line that touches only one point on the graph. Let me draw a parallel line that touches only one point on the graph. Do you see, guys? At this particular point C, this C point is between the open interval AB. So at this point, the slope at this point, slope at point C, what is that called? That is called the instantaneous rate of change at point C. That is called the instantaneous rate of change. Slope of the tangent is the instantaneous rate of change, right? Instantaneous rate of change. Okay, so now this at C point, if you take the instantaneous rate of change, that is the slope at point C, that is exactly equal to the average rate of change. How? Because these both the black and the blue are lines are parallel and their slopes are equal. However, the black line is a secant, the blue line is a tangent. So that's why the slope at point C is instantaneous rate of change. Slope between points A and B is the average rate of change. So if you're able to draw a parallel line to the black line in such a way that the blue line is just a tangent to any point on that graph, then in that case, you can say at point C, the instantaneous rate of change is equal to the average rate of change over that interval, open interval. Any questions? Any questions? Any questions, guys? Okay, can I move on? Okay, now let's go ahead and do some problems. We started doing, but we didn't. How about this? Okay. I really want you to try this one. I really want you to find that C value. I really want you to find the C value. Let's see. What is the C value? I've given you f of x. I've given you an interval 4 to 6. I've given you f dash of x. What is f dash of x? Who can tell me? What is f dash of x? I know that this is derivative of x, but what is it? What rate of change is this? What rate of change is this, guys? What rate of change is this, ma?
For the equation?
No, there is two rates of change, right? One is the average rate of change. That is the rate of average rate of change is the rate of change on C. For any graph, if you draw a secant between 2 points, right? You calculate the average rate of change between these 2 points, f of b minus f of a by b minus a. What is instantaneous rate of change? Instantaneous rate of change means what? That is how we define our derivative, right? Instantaneous rate of change means what do? You take only a particular point on the graph and draw a tangent and say the slope at that point. That is instantaneous rate of change. That means that's the derivative of the function f of x. You write it out as f dash of x is the slope of a point on the graph. Make sense? So here, what is this f dash of x? I asked you. What rate of change is this? I asked you. You're all with me, huh? Or you're not
Yeah,
getting?
I'm thinking.
Yeah, so there is two things, guys. On a graph, if you draw a secant, you can only get average rate of change between these 2 points, correct? Because the graph touches 2 points. But if you think about 1 point, let's consider this 1 point on the graph. You see? So this is 1 point on the graph. If you find the slope, right, in that case, that is called the instantaneous rate of change. Another name given to it is derivative of the function at that point. Okay, derivative of the function at that point is always given this notation f dash of x. If this is f of x, if the graph is f of x, the slope of the tangent at a particular point is otherwise called as the derivative of that function at that point. Now I am asking, what is this? This is
Oh,
the
you just
derivative of f of x. What rate of change is that?
you just find the average rate of change of the function equated to a derivative.
Exactly. You just find the average. So what are they saying here? So correct, Manav. That's what you need to do. Finally, you got it, I think. So f of x and f dash of x is given on that interval. We want to find that point C. What is that point C? C is the point where we want to find point C. Point C where? Point C is where, per mean value theorem, that is the point where your instantaneous rate of change is equal to the average rate of change. Okay, first of all, what is the average rate of change here? How to calculate that? For the function average rate of change for the function f of x will be equal to f of 6 minus f of 4 by 2. Any questions? 6 minus 4 is 2. What is f of 6? Minus 2 times 6 square plus 16 times 6 minus 26. Then you have a minus, substitute 4. Minus 2 times 16 plus 64 minus 26. Divided by 2. What is that, guys? 6 6 are 36. 72 minus 72 plus 96 minus 26. So that would be divide by 2. But again here, you need to extend this. So this would be plus 32 minus 64 plus 26. Shall we go ahead and work this out? What do you get here? So 72, okay, this one becomes minus 32, right? And then what? 96 minus 32 is what? 64. Minus 72 plus 64 is what? 8. Minus 8 by 2 is minus 4. Any questions? This is the average rate of change. Now, if that is equal to the instantaneous rate of change, this is the derivative is the instantaneous rate of change, right? So, minus 4x plus 16 equal to minus 4, right? Minus 4x will be equal to minus 20, x is equal to 5. So, at 0.5 between this interval, when x equal to 5, we would be able to draw a line that's parallel to the secant that connects 4 and 6. Am I making it clear or no, guys? Yes, no, you can tell me anything, but just let me know. Manav, did you understand?
Yeah, I understood.
Okay, how about Krish? Did you understand?
Yeah.
How about Dwani and Arush?
Yeah, I understood.
Arush,
Yeah.
you?
Yeah.
You got it? Okay. Okay. I would really like you to start using the calculator to find the derivative next. This one we have never done. Do you know how to find the derivative in the calculator, or do you want me to show you?
I I know.
You know? Okay, Dwani, do you know?
No.
Okay, okay. So there is at least one person. Okay. So x cube by ln x, that is your function. You need to find the derivative at point 0.57, meaning when x equal to 0.57, I would like to find the slope of the tangent. If they ask you, they might ask you in different ways, okay? They might ask you to find the derivative, or they may ask you to find the slope of the tangent at that point. Both are one and the same. They are just asking you to find the derivative at some x point. Okay, x cube by ln x. So let me go to TI-84. Calculator, you know what? I need to inform the next class. Not TI-84. Have to share the screen, guys. Stop share, share. You see the TI-84 calculator? You're seeing, right, guys? Hey, you're able to see the calculator? Yes, no.
Yeah.
Okay, thanks. So, what was the question? I forgot the question. X cube by ln x at 0.57. So, the question says function is x cube by ln x. And then you're going to find what? F dash of x. That means derivative of, derivative of f of x. We really want f dash of 0.57. That's all. Okay. So how do you do that? Okay. You go to, first let me type the function, bracket x power 3. Power is where? Yep. Come down. Divide by ln x, right? Divide. Oh my God. This is so bad. Okay. X cube divide by ln x bracket close. Sorry guys. Really? Okay. Okay, divide by ln x, close bracket. That's it, right? Oh, two brackets. Okay, now go to second, I think math. Where is math? I should have. No, I don't want the second to be pressed at all. Okay, now I want to go to math. In that, see nth derivative. You have derivative, right? So press this. Oh my gosh. Okay. Okay. Okay, guys, let me go to ordinary screen. Babe, how do you go to ordinary screen? Quit. Okay. So I can go ahead and do that one directly here, I think. So instead of going there to the function at all, I can directly go here and say math derivative. Let's find out. Yep. D by dx. Okay, d by dx is also another term, another way. Notating derivative can also be done using d by dx. Okay, what am I going to say? X cube, right? X cube divide by ln x, right? And then you go here, okay? See, that one tells what is the x value for which you need to find the derivative. Then press enter, it gives you the answer. This is the answer. Any questions, guys? You don't need to go type the function at all. You can directly go to your usual calculator screen, then go to math. In that, you can select derivative and then type the function, give the x value, it will tell the answer. Can I move on? Can you move on, guys? Any questions? Yes, thanks. Oh, wow. Okay. Okay, nice. Okay, how about this? Using the calculator, we did it. Ah, this is a good one. Okay. Okay, guys, I'm going to take this function. I think you all have seen this function, okay? Okay. Let me share my screen. I'm not sharing my screen, right? Okay, we are going to do something very important, okay? This one is very great, okay? Let's see this one. Do you see the function here? Okay, this is f of x. I'm going to find out f dash of x. What is this? I'm going to plot the derivative of the function f of x. How do I do it? What is f dash of x? I select a point. I draw a tangent. Slope of that tangent is f dash of x at that point. So, at let's say this is 4, minus 4, minus 3, minus 2, minus 1. Let's consider that that is the, I've given some random numbers, okay? So at minus 4, how is the slope? How is the slope of this function at minus 4? Then at 3.5, minus 3.5, how is the slope of the function? At 3, how is the slope of the function? Can you guys tell me? What happens to the slope? Select each point. 1, 2, 3, 4. How does the slope vary? Can I say, can you describe the slope at this point? Is it too steep or less steep, or what do you say about the slope at that point? Yes, I really want you to answer. How is the slope of the graph at that point?
Uh, as you go further down the graph, it gets steeper.
As you go down, it gets steeper, right?
Yeah.
That's nice, yes. 1 second. Oh my God, I don't have the 1 second, guys. Sorry. You're going to give me a minute, okay? I'm not able to write on the board. It's not so good. Give me 1 second, guys. I'm not able to write on the board, guys, so just be patient. So slope as you go down, it is steeper, right? So let's start at this point. Okay, what can I say about the slope at the bottommost point? Let's say -4. Can I say slope is positive or negative, first of all? Slope is positive or negative? Please tell me, guys. Slope is positive or negative? Draw
At that
the
point,
line, guys. Slope is positive. Upward going line or downward going line?
upward,
Upward. So it is positive or negative?
positive,
Positive, right? High positive. Can I say large positive? Why? Because it's very steep. If you draw a slope almost like a vertical line, it's slope. It's high. If I draw it like this, it's medium. If I draw it like this, the slope is reducing. How about this point? It's pretty much the same. And it is large positive, right? How about at this point? Is it reducing? The value, is it reducing or is it still large? What do you think?
it's reducing.
Yeah, medium positive. Guys, I am literally telling nicely, these are the conceptual fundamentals involved in derivative. Okay, let's go ahead in this one. Let's go ahead. When we learned, we didn't learn it this way. Okay, so let's go ahead. How about this? Is it reducing from here or how is it? Can I say small positive? What happens right smack at this point? What happens right smack at that point? What happens to the slope of the tangent? What is the slope of the tangent at that point?
0.
0. Okay, how about this?
Some
Can I
negative,
say medium positive?
medium negative.
Medium negative, I'm sorry. It's a downward going point, correct. Okay, now here, see, basically it's a little bit negative, a little large, a little more than medium. Right? How about this point? What happened to this point? How is the slope of the tangent at that point? Krish or Dhwani? Krish or Dhwani?
Um,
How is the slope at this point?
it's 0.
0. Again, what are we doing here?
It's increasing to
It's
positive.
increasing. Yep, it's almost becoming a vertical line. Large positive, small positive, medium positive. Okay, let's try to graph that. So what are we achieving by this? We have a function f of x. Okay, we are selecting various points in the graph. We are finding the slope of the tangent at every point in the graph. So what are we doing? We are finding the slope of different points in the graph. The slope of tangents. We are finding the slope of tangents of different points in the graph. So we are trying to draw the graph of derivative of f of x. Derivative of f of x is the slope of the tangent at particular points. Okay, so we are doing that for several points in the graph so that we can come up with the graph for the derivative completely. This is our f dash of x. Let's plot it. We said positive large. So let's say -4 was positive large. Then what happened? Again, -3.5, right? -3.5 was little large. -3. What happened to -3? What did we say? Medium. Medium positive, right? I made a mess here. -3 was still big. Then what happened? We went to this point, small, oh, okay. We again had another point, -2.5, where it was small positive. 2.5 where it was small positive. And then at some point minus 2, it was a 0. Okay. So we are plotting all these points where we found out the derivative, where we found out the slope of the tangent. Then what happened? It became medium negative. Medium negative, large negative. It became medium negative, and then large negative came into picture when it was positive 1. When it was a positive 1, it became large negative. Then what happened? At 2, let's say it became a 0 again. And then small positive, medium positive, large positive. So what happens here? What are we achieving? This is the graph of a cubic function. How is the derivative of the cubic function? What is the graph of the derivative of the cubic function? It is a, do
Quadratic.
you see, what is it?
Quadratic.
Quadratic. So what do you infer from that? The cubic function's derivative is a quadratic function. Does that make sense? Does that make sense, guys? Honestly, when I studied, we did not do this sort of understanding to the core. So I really want you to understand how are we relating this graph and this graph. We want to draw the graph of the derivative of a function f of x. So we took up a cubic function. There is a graph, cubic function graph. We took up several points, drew tangents at every point, and found what is the slope, what is the slope, what is the slope, what is the slope of the tangent at that point, what is the slope of the tangent at that point, what is the slope of the tangent at this point, at this point, what is the slope of the tangents at every different point of the cubic function we found out. Then we made a note of the y values. So y value of this graph is what? Slope of the tangent of different points of different x points in f of x graph. Make sense? So the derivative, we are trying to draw the graph of the derivative of a cubic function which turns out to be a quadratic function. Can I move on? Dhwani, did you follow through, ma?
Yeah.
Okay. Okay. Now let me move on. Here. Okay. So now you got that. Now we are going to do some problems. Okay. Before we do problems, right? Next week will be full of problems. I want to cover one more topic whatsoever. Okay. I want to get into derivatives and just keep moving. Okay. Already I said there are different ways of denoting derivative, right? I will either use this as one of my notation or I will use this as one of my notation. Makes sense? These two are the famous ones. I'll be either using that or this going further. Okay. Now, I know we didn't do any problems in this, right? We didn't do problems related to differentiability. We didn't do many problems related to differentiability. So definitely we will do, but I want to cover one more fundamental concept, okay, of derivatives, okay. We were doing derivatives by using this, right? Limit h tending to 0, f of x plus h minus f of x divided by h. This is what we were doing till date. We were doing the roundabout way. You all asked, can't I do the derivative quickly? Are there no formulas? Definitely Arush asked and Mano asked. I said, no, you'll have to do by this. But now it's high time we are going to do differentiation using rules. Okay, as a part of it, for the first one, we are going to discuss the power rule. You now understand that the derivative of a function is nothing but the slope of the tangent at that particular point of the function. That you need to memorize. It has to be in your brain even if you wake up from sleep. Now, coming to power rule. Okay, when suppose let this be a function f of x. Okay, for this function, if I want to write my derivative, right, there is a rule for this. Okay, you write the power x power of n minus 1. Why is it like this? Remember, you took a quadratic function. You drew the graph of the derivative. It turned out to be a quadratic function, right? Cubic function was n. So, your derivative was a quadratic function and your power comes here. Make sense? This is the first rule that we are studying. Any questions here? Okay. So now, guys, this is very important from now on. Okay. Let's go ahead and try this one. I'm going to give f of x equal to 3x power of 7 minus 4x power of 5 minus 1 by 3 x cube plus x square minus 3x plus 7. How am I going to get the derivative of this function? Arush, now you should be happy, right, Arush? F dash of x. This is what you were telling me 3 weeks back, 4 weeks back, right? Remember?
Yeah.
How do you differentiate this? You write the 7 x power of 6 minus 4, you write it down. Then x power of 5, how do you differentiate it? 5 times 5 x power of 4 minus 1 by 3. Again, you put 3x square plus 2x minus 3. Differentiation of a constant is always 0. Differentiation of a constant is always 0. So, now the derivative of the given function is 21x power of 6 minus 20x power of 4 minus x square plus 2x minus 3. Any questions?
So like every time like there's a function like this, the derivative is like a power lower.
Come again, ma?
Like every time there's like a bigger function like this, the derivative is a power lower.
Correct.
Right?
That is what we saw in the graph, right? Did you understand? X cubic graph became a quadratic graph, right? That's where you
Yeah.
understand the basic concept of differentiation, how it came. Right? And we don't want to be doing always, don't substitute instead of x, you substitute x plus h. Remember? F of x plus h minus f of x divide by h. We don't want to be doing that as well. We want to learn the, already mathematicians have derived so many formulas. We are going to use that. So first is the power rule. Power rule says when you differentiate x power of n, it becomes n x power of n minus 1. Can I move on?
Miss Priya.
Yeah, go ahead.
So I didn't quite understand what happened to the 7.
Did I miss something? The 7 came here. X power of 7
No,
minus 1, 6.
the 7 at the end.
D by dx of a constant is 0. Constant is a number, 7, 10, 11. There is no x means it is 0. This is x power of 0, right, ma'am?
Yeah.
So, the x power of 0 is 1. So, basically it is a constant number, right? You got it?
Yeah, I got it.
Okay. Any other questions?
No.
Okay. Now, f of x. This one you're going to try, guys, okay? This is a little tricky. You want me to do this as well? I'll give you one more next time because there is a negative power. There's a negative power, remember? So power rule says d by dx of x power of n will be equal to n x power of n minus 1. Please memorize this. There's more to memorize, okay? This is the first one in the lot that you'll memorize. Okay, now 2 is there, n is this, okay? X power of n minus 1 plus 4. See, what happens here is x power of 1 is there, right? So 4 times 1, n, x power of n minus 1 is x power of 0. X power of 0 is 1. That's why we get 4 times 1. And then differentiation of this constant pi is 0. So what happens here? Minus 6 x power of minus 4 plus 4x. Minus 6 x power of minus 4, how do you write? Minus 6 by x power of 4 plus, sorry ma, this is 1, right? This is 1. This is your answer. This is f dash of x. Any questions? See guys, when there is a negative power, you need to be very careful. Okay, 2x power of minus 3, the differentiated term becomes minus 6x power of minus 4. So you need to be a little careful. So always n x power of n minus 1. Okay. Dhwani, did you get it?
Yeah.
Okay, how about this? Maybe this one as well, I feel like doing it, but if you want to give it a try, you're more welcome to. Do you think you can handle this? I'm just pushing it through, guys, because see, when we cover only one topic every week, we are never going to complete even AB calculus. Okay. See, that's why I decided to go in for AB calculus, because looks like so many things are new, and we need to cover at least 2 topics on some of the weeks, 3 topics on some of the weeks. Then only we'll be able to finish properly. So do you think you can write it as powers and get me the final answer, guys? Do you think you can arrive by yourself, or do you want me to do it on the board? Please let me know.
Can you do this one on the
Yeah, absolutely, I can do. That's what I wanted to ask. Okay, let me go ahead and do it here. Okay, f of x equal to, how do I write this? X power of 7 by 3 minus x power of 1 by 2 plus 2x power of 2 by 5. Any questions? Any questions in writing it as a radical? This is what we learned in algebra 2, right? Or in algebra 1, where we learned radical power, radicals. This is a radical, right? Can be converted to rational exponents, fractional exponents. 7 divided by 3. So I rewrote it. Dhwani, did you follow, ma? 7 by 3, x power of 7 by 3 minus 1. Minus half x power of half minus 1. Then plus 2, 2 by 5, x power of 2 by 5 minus 1. Any questions? 7 by 3, x power of 4 by 3. That's not a minus, 4 by 3. Then minus half x power of minus half plus 4 by 5 x power of minus 3 by 2. Any questions? Are you all with me? Guys, it becomes a little complicated as we move further. 7 by 3. What is this? This is x. Can you write it as a radical? X and then cube root of x minus half. See, basically it is 1 by x power of half. So can I write it like this? Plus 4 by 5. Basically, it becomes x power of 3 by 2. But that I need to write it as a radical. Okay. So 7 by 3 x cube root of x minus half square minus 1 by 2 square root x plus 4 by 5. See, 3 by 2 is x times square root of x. Who did not understand this? I need to be able to explain this. So please ask if you did not understand. It's high time you understand this. If you did not, then we need to slow down. Did you get it? Hey, did we do a proper job? Is this right? Is this right? Fifth power. 1 second. Let me see. Did we take it as a fifth power? Yeah, we took it as a fifth power. That's right. So what happened here? We made a mistake here. See, that's what I thought. 4 by 5 x minus 3 by 5 m. See, that's what the fifth power disappeared. I was wondering. So this then becomes x power of 3 by 5. Then that becomes, what is that? X cube. So 5 fifth root of x cube. Any questions? Any questions?
no.
Is it clear? Guys, did you get it?
Yeah.
Let me go ahead and give you the problems now. So you all got it is what I'm assuming. So we'll do work on problems. Okay, how about this, guys? Let's do this one. Okay, let's do this one. F of x equal to 1 by x plus 4 by x square minus 1 by 3x the whole square. I need to find out f of x. Can we do it? There should not be any negative powers of x. Okay, can we do that, guys? I'll wait. You're going to send the answer, please. Or I'll ask you term by term. Okay. First term Krish say, second term let Manav say, third term let Dhwani or Parv.
I say the second term. Okay, I'll say the second term.
Miss Priya, you're on mute if you're trying to speak.
Yeah, I'm trying to speak to you only. I don't have anyone at home. Yes. Thank you, Ma. I didn't realize that I was in mute. Manav, that's right. Second term is right, Manav. Parvini, that doesn't seem right, Ma. Do you want to do it on the board or do you want me to do it on the board? You have to let me know.
Miss Priya,
Yeah,
for the third term, is that a 2? Is that 3x to the power of 2?
3x to the power of 2. You can send the third term as well for you to check. Dhwani, did you get it?
I didn't know if that was a 2.
No problem. Now that I clarified, you can proceed. So, did you get the answer, Christian Dhwani?
Yeah, should I send you only the first term or
Yeah,
all, like
first
the
term
entire
only you
thing?
sent. Yeah, see, for you need to be correct. That's all. Okay. Whatever you feel like you just send, I'll just say whether it's right or not. That's all.
Miss Priya,
Uh-huh.
how is there a third term? Because it's gonna come as a linear answer since this was a quadratic.
This is not a quadratic, right?
Not like a quadratic,
The
but like the
denominator is
highest
x. Ma, the
x
denominator is
power.
x square, ma. It is not x square, right? It is x power of minus 2. That is 1 by x square. It becomes a rational function, right?
Oh, okay, I see.
You see, so you'll have 3 terms. So this one is minus 1 x power of minus 2 plus 4 times minus 2 x power of minus 3. See, the powers become bigger, meaning bigger negatives. So minus, so basically what is this? 1 by 3x power of 2, right? So 1 by 3x power of 2. So this is 3 square basically. And after that, you get 2x power of 1. So basically it is 3x square, right? If you do this, right, I'm going to first find the derivative. Let me write out the derivative. Okay, this would be what? Basically, I have 1 by 9. Okay, let me write out that 1 by 9. And then I have x power of minus 2, right? So I will write it out as minus 2 x power of minus 3. So that becomes, Parvini, are you following?
Yes, Auntie.
Huh?
Yeah.
That is your derivative. No, if you're missing something, ask, right? That's why we have gotten only a very small group of you. And we want to make sure you all understand and move on as well. What is that you didn't understand, Parvini?
So for the third term, I'm a little confused how.
Okay, third term, you're a little confused. Okay, I got it. Okay, let's go with the third term. So this was minus 3x power of minus 2, correct? So what is happening here? Can I write it down as 3 power of minus 2, x power of minus 2? Only the x is going to be, you'll have to find the derivative. Okay, what is 3 power of minus 2? Can I write that out as 1 by 9? Can I do that? Now I have to find the derivative, right? So I will write minus 1 by 9. How to find the derivative of that? N is minus 2, right? X power of n minus 1. You got it?
Yeah, I
Minus
got it.
1. Minus and minus becomes plus. So 2 by 9 x power of minus 3. That I can write it down as 2 by 9 x cube. That is, what is this? Make sense?
Yeah, I got it.
Krish, did you get it?
Yes.
What else? Who else didn't get it? Guys, did you all get it? Arush, did you understand?
Yeah, I got it.
Okay. That's a hard one. Okay. Okay. Can I give one more? Can we do one more? We'll do 3 more. Okay. Then yeah, we'll do a few problems, guys, because it's something very new. So let's try this one. F of x equal to minus 16 x square plus 5x minus 1 by 2x. Can we try this one? You know how to do this? I just want to know. You can send the derivative. It's a simple one, small one, so you can send the derivative.
Spirit, for this one, did we do individual like negative 16
Correct, correct. You do
over
individually.
2x?
Yes, yes, yes. You do individually. But in another two subtopics, right? You have a formula for this numerator by denominator in differentiation itself. That we'll do a little later. But for now, you can divide each minus 16x square can be divided by 2x. 5x can be divided by 2x. Minus 1 can be divided by 2x. Do that first. I think that should be right, Arush. Oh wow, Arush, that's right. Manu, that's right. Manu. Is your sign on the second expression correct?
On the second one?
Yeah.
Oh, because it's minus. Oh, yeah.
You see what I mean?
Yeah.
Yeah. Parvini, Dwani. Try, guys. If you did not understand, I'll help you guys. Wow, Manu, that's right, Manu. Parvini, yes, Parvini. I think that's perfectly right, is what I'm thinking. Krish, did you get it? Not really, Ma. Dwani, how did you do?
I mean, there's more, but I wasn't sure about the other terms.
Let's do one by one, Ma. Minus 16x square by 2x, right? Plus 5x by 2x. Dwani, for you only I'm doing this, 1 by 2x. Here this becomes minus 8x plus 5 by 2 minus 1 by 2x, correct? But let me rewrite it, plus 5 by 2 minus 1 by 2 x power of minus 1, right? That is f of x. dy, let's say this is y. dy by dx will be what? Minus 8. This one becomes 0 when you differentiate. Then minus half you write. Then you bring the minus 1 x power of minus 2. How do you rewrite it? From here we'll write it. Minus 8 plus half x square comes down. That's your answer. Did you get it?
Yeah, I did the calculation error in the beginning.
But you got it, Ma? Now?
Yeah.
Okay. It takes time though. Okay. I don't mind at all, but you have to understand when we move on. Okay. We are in the class. Okay. How about this? I'm going to give you a few questions. Okay. One, f of x equal to oh my god. 1 second, guys. half x power. Did I write the half? Okay, half x power of 4 minus 4 x power of minus 2 plus e. Second question is y will be equal to 1 by square root of x plus 4x. You know what I'm going to want to find? Find dy by dx at x equal to 4. Please do both. Here you know what I want to find. I didn't tell you. Find f dash of 3. So what are they asking? F dash of 3 means what? Find for this function when x equal to 3, find the slope of the tangent at that point x equal to 3. That's what they're asking. You know, my battery is going low.
Let's get rid of the constant, right, when finding the derivative.
Find the?
When finding derivative, we always get rid of the constant, right? Like e.
Yeah, ma, correct, ma.
Can we use a calculator for this question? Like just to plug in the value?
You want to try? Yes. Manav, since you know the conceptually you do, but yeah, those of you who are not yet fully getting it right, don't use calculators. It's for you, you're doing, okay? At the end of it, if you get it wrong, just ask.
Should it be like a decimal answer once we solve for 3?
Right, give it in fractions, ma.
Fraction? Okay.
Yeah. Okay. You can do this. Okay, I'll get the charger.
I sent you the derivative for the first one. I'm not sure if it's right, so I didn't calculate for 3 yet.
Absolutely, I'll check, Dhwani. If you don't get it, again, I'll explain. I am checking. Oh. For the first one, you send the answer. Huh? Wonderful. I don't have the final answer on the first one. Can you give me a mixed number? Huh? Did you give me a mixed number? Mixed number is easier, I feel. Oh, you gave it like that. Huh? That's right,
Yeah,
Dhwani. Yeah,
'cause
but then But then if you're asked for f dash of 3 means substitute x equal to 3.
Yeah, I did substitute 3 and I got like a really large fraction.
Yeah,
That's why I wasn't
just put
sure.
it as a mixed number, ma. Just put it as a
Okay.
mixed number. You get a 54 plus something, right? Write it as a mixed number.
Oh, okay. Okay.
Arush. No, Arush. That is not correct. Is it minus
Yeah.
265 by 16?
No. 65 by 16 was supposed to be for the other one, but I took everything something wrong.
65 by 16 or 63 by 16? I don't know. Oh my goodness. Parvini, you are making my brain work now. Wait, 54 times 27. Wait, 54 times 27 plus 8. 54 times 27 plus 8. Parvini, I'm not getting your answer, ma. 1450. Wow. I'm getting 1466. I don't know. Okay. It's interesting. Krish, what did you get? Manav, you got the answer, Manav?
I
These
sent
are
my
hard.
answers. I'm not sure if they're
Not
right.
yet.
That's absolutely okay, Krish. Not a problem at all. We are just learning now. Yeah, that's correct. Yeah, that's right, Krish. Both are right. Parvini, you had answered 1450, right, ma? 1450 is not correct, ma. But that's right, Dhwani.
I made a mistake, Auntie. I fixed it.
Oh, okay, no problem at all. If you understood, I'm fine. So f dash of x will be equal to half 4 power of x cube minus 4 denominator. So this will be a minus 2 x power of minus 3. E will be 0 when you differentiate. Okay. So this will be 2x cube plus 8 by x cubed. So f dash of, what are they asking? 3. Yeah. So 2 times 3 is 9, 9 is 27 plus 8 by 3 is 9, 9 is 27. So that would be 54 8 by 27. Or if you convert it to an improper fraction, I think it is 1466 by 27. Any questions? So are all new to you, right? But you know what? If you know this, by the time your school comes in, you'll be very happy. Meaning, it'll not be a burden to you at all. That is there. But for me to keep up with this pace, we really want to move forward quickly. Manav, 173 by 3 is incorrect, ma. 63 by 16 is correct. Manav, the first question just now I did it, right, Manav? Did you see that, Manav? The first question was this. For some reason, yours was incorrect. Did you see? Where did you make the mistake? Did you identify the mistake? JSI, your class was not started, JSI. It is 15 minutes delayed, ma. 15-20 minutes delayed, ma. I hope you saw the message.
So it's 7:40.
It is, no, ma. Usually it is at 7:05, right? I had put down a message. Is your mom there in that group?
Yeah. I was just gonna like join early. That was why. I had some doubts and to something.
Absolutely okay. If you want to be here, be here.
Yeah.
You're
There's just like some things I needed to talk to you about before the class started. That's why I went.
absolutely. Just wait. This is going to get over too, so you can just wait.
Thank you.
Are you done, guys?
Could you do the second one?
What, ma?
The second question? The
Second
dy
one,
over dx.
shall I do it?
Yeah.
Oh, sure. So here it would be x power of minus 1 by 2 plus 4x is your f of x, correct? I'm doing it in black, ma, so that you understand. Okay, minus half, oh my god, minus half x power of minus half minus 1 plus 4. So that would be minus half. This is minus 3 by 2, right, ma? So when it comes down, it becomes x power of 3 by 2, but that is x square root of x, correct? Plus 4. So when you substitute 4, right, f dash of 4 becomes what? Minus 1 by 2 times 4, square root of 4 is 2 plus 4. That's all, ma. So what are we getting? Wait, I don't see what I'm doing. Oh, what happened? Minus 1 2 to the 4 is 8, 8 is 16 plus 4 minus 1 plus 64 by 16, which is 63 by 16. Did you understand, Dhwani, the second one? Manav, did you understand the first one?
Auntie, I have a question.
Yeah.
Yes.
So for the second one, when you multiply x square root of x to the negative 1/2, why are we putting it in the denominator?
Because this thing becomes minus half x power of minus 3 by 2. How to remove the negative power?
Oh,
Minus
do we
half
automatically
times.
put that in the denominator as well?
Huh?
Do we put the x negative 3 by 2 in the denominator as well?
Yeah, see, x3 by
Okay.
2 comes to the denominator. But x3 by 2 is what? 2 by 2 plus 1 by 2, right? So 2 by 2, x power of 1 plus square root of x power of 1 times square root of x, right? Okay, I think you forgot this. X power of, this is x power of 2 by 2 plus 1 by 2. I can write it out as x power of 2 by 2 times x power of 1 by 2. Correct, ma? 2 by 2 is 1. This is square root of x.
No, I got that. No, I was just confused because we were writing it as negative 1/2 times x to the power of negative 3 by 2. And then when we changed it to the fraction form for the x power, we put that in the denominator instead of...
I didn't get you. Meaning I didn't get you. Guys, if you all others got it, we can stop here, guys. If all the others got it, we can stop here, please. Parvini, you stay.
Okay.
What did you not get? Manav, you can log off. Krish, you can log off. Arush, you can log off. Dhwani, if you understood, you can log off.
I'm not sure I'm understand.
Sure.
Thank you.
Bye. See you next week, guys. All the best, Arush.
Thanks.
What is your question, Parvini?
So my question is, so you wrote negative 1/2 times x to the power of negative 1/2 minus 1, right?
Correct. That becomes minus 3 by 2, right?
Yeah. So my question is, didn't we multiply them separately? Then how did the x go in the denominator?
Okay, you have this problem, right? X power of minus half. How did you factorize? You're asking, right? The differentiate, right? Is that your question?
Can I write on the board?
Yeah, please.
Okay. So we wrote negative 1 by 2 x to the power of negative 1 by 2
N minus 1. N x power
minus
of n
1.
minus 1, right?
Yeah. So my question is, why didn't we just do negative 1 by 2 divided by x to the power of negative 3 by 2?
You can, yeah, you could. That's what I did here. I did the same thing here. That's the same thing as this. It's the same thing as that, right? Minus half times x power of 3 by 2, right? X power of 3 by...
I see.
You got it?
I got it.
Okay, bye. Bye.
Okay, thank you.
Bye, ma.
Bye.
Bye. JSI, what is your question? JSI,
Man,
what's your...
so basically I was struggling with like the last week's homework. I wasn't understanding like when we got to like the absolute like the first paper I did well, but then when it got to inequalities I couldn't solve them at all. Like it was
No
like very
problem.
hard for me.
No problem. Can we redo that from the homework?
Yeah, sure. Also, one more thing, man. So our Algebra 2 teacher, like the one that makes the most of the tests apparently, he has he's very smart, man. To be honest, all of the students that I met with so far that already had him are very scared of him. He makes the test extremely hard, and it's and he gives us grade point curves, averaging like from the to the kids that are in college second year from their scores and our scores. He grade points them, like curves them. And so we had our first couple of quizzes now.
Yes.
We had 4 quizzes, speed quizzes. we had to solve factoring 30 questions in 5 minutes. And then that was A equals 1, and then A is greater than 1. We had another paper, and then it went to linear equations. Sorry, transformations and exponents. And one last thing was systems of equations.
Okay.
So far, the results came out for only A equals 1. I got like a 92 out of 95 so far. I mean, 100. And then systems of equations, I haven't done well because like I got to like the last two questions and I couldn't solve them.
Doesn't matter. Okay, tell me.
So then on Tuesday they said we could reassess, but on Monday we have a unit test for the Algebra 1 review.
Okay. How shall I help you? Tell me. I get it. I get the picture. Okay. I understood, what you got marks on, what you didn't. Okay. So how shall I help you? I have some thoughts. You go ahead.
So I wanted help on like the systems of equations, like how to finish them quickly, and like if there's any way to like do factoring A equals 1 any faster, like instantly eliminating unfactorable ones or like finding them quicker.
Do you know how to use the quadratic formula?
Yes, no.
Have you used it during the test?
No, because then it would take too much time. We only have like 5 minutes for 30 questions.
5 minutes for 30 questions.
So
What
like around
type of
20,
questions? They'll be easy then.
not really, ma'am. Like it takes a bit of time.
Okay, shall I show you a place to practice all this?
Uh-huh.
I'll do that. I'll do that. Shall I let
Okay.
the others in and as well tell them?
Mm-hmm.
Yeah, we can talk after the class as well.
Okay. Thank you.
Hi guys, how are you all?
Hi, Miss Priya.
Hi, Keyura.
Hi, Miss Priya.
Hi guys. Hi, Srishti. Guys, come on the video, guys.
Yeah, give me 1 second. I just need to.
You take your time. Okay, who is this Kalyan Chakravarti? Okay. Shall we go ahead?
Miss Priya.
Yeah, ma. Looks
For
like
I
last
was
week's homework you were all struggling. That's the feedback I got. Did you?
Yeah, I was only able to do one of them because I hadn't learned the stuff, and I learned some of the stuff in the other homeworks this week in school, but other than that, there's still stuff I don't know how to do.
Don't worry at all. Let me go back. What is that
Okay.
difficulty? Let's see. Avyuk, were you able to solve the homework?
I'm not able. I was trying to get used to his school schedule, so I'm sorry.
I hear you. No problem.
Yeah.
Okay, so let's see this. Advanced algebra 2, right? Mhm. Okay, which one do you want me to review first? I am open to whatever, meaning I'm not going to move forward unless you guys understand. So which one do you want me to solve first? One by one we can go, but tell me which one first.
Can you do the absolute value functions review?
Okay, I'll do that. Okay,
Thank you.
Desai, which one are you suffering from?
It's the same one, the absolute value functions.
Okay. These are hard ones, honestly. I'll be honest with you, but I'm just telling. This was a hard one. I went through. Okay. Yeah, we can do that. Okay. Apart from that, okay. Do you all know this website, guys? I really want you all to know. Okay. You're all going to prepare for SATs. You're all going to appear for ACTs or whatever, right? But the thing is, several of us, what we do, we don't do any competitions outside or anything outside. So as a result, we tend to forget and the speed becomes low. Your speed reduces, first of all. Second thing is, you tend to forget what we learned 2 years back. This is always the case, and that's why many of you are needing SAT coaching. You don't need SAT coaching at all, provided you remember what you learned. Okay, so let's see here. You know this website? Do you all know this website, guys? Okay, you don't know. Okay, there's a free resource. Okay, usually in school-based classes, I don't get. I don't want to. Okay. Usually in school-based classes, I don't get to this at all. But I feel like some of you in this, oh, it doesn't sign in. What is this? I have some problem with my browser. It never signs into that site. Okay, so Let me share something, meaning let me share another browser with you, so that way. You see how I did that? Did you see, guys? I went to Google this one, right? Okay, now when I go here, I don't want this profile. Okay, let's go ahead with my profile. Okay, it doesn't even sign in. Yeah. Okay, now you see here. Do you see here resources? Please, you'll have to remember this. You need to get access to this, means you will have to create an account for yourself. For that, your mother or father should sign a PDF file and send it to these people. Then only they'll give you access, okay? It is a task, but it is worth the task. Worth means whenever you have time, you can sit and do these problems. Do you see in resources? Meaning you open the site, you create a login. Login process is not that simple. It will take 2-3 days for you to get access, okay? They should approve. Once you send the waiver to them, they will approve. Yes, we can definitely discuss, okay? Now going here, right? You have resources, right? In resources, do you see alchemist? You all see that, right? When I go here, if you have doubts, you can always message me how to go, but please write it down, guys. Then you don't have to definitely ask me. You should remember resources, alchemist. Just play. When you play, right, the biggest thing here is, do you see that change focus? Do you see the change focus? I go here. You see pre-algebra, algebra, number theory, counting probability. So many things are here, right? Select intermediate algebra. Okay. All of these are what you learn in algebra 2. Make sense? Now, I brought up a very good point that his teacher is a very great teacher who gave some reviews from algebra 1. Okay, that was speed based. This is algebra 2. You guys have not been exposed to at all. So basically, where is that absolute value function? It's not even in here. Why? You will expect absolute value function in here. Inverse functions we covered, remember? Composition we covered, remember? See? Graphing functions, domain and range, these all you can handle. You don't know about complex number arithmetic, don't worry about it. You don't have to go here and practice, okay? But what else? We have not covered any of these, so you better go to algebra. When you go here, do you see two variable, solving two variable system? JSI, do you see it here? Set
Yes,
new
ma'am.
focus. If you do that, see, there'll be two. See, as soon as you see this, you can time it and practice. You can time it and practice these. Here, it'll be so useful for SATs. Okay, meaning the thing is, you guys do not have additional exposure to math other than what you do in school. There's no way you'll remember geometry after 1 year when you take the SAT. So the best thing is, please, whenever you have time, go here and keep practicing. You don't need to go for SAT coaching and stuff. So here, you see, go back and do all the problems in here. It's absolutely free and the quality of problems is so high. You got
Can
it?
you send this in the WhatsApp group where our parents are?
No. You
No.
didn't note down why.
I did note down. It's just that
Recording is
so
there,
my
right?
parents know the link.
A link I can send, definitely. But
Yeah.
I don't want to write out this big of
I
a.
can tell my parents how to sign up. I just want them to have the link so they can
Absolutely.
easily access it.
Yeah, absolutely. You have a point, okay? So I have to accept it. I will send. But please don't make me write the entire how to go alchemist,
No,
set
it's
new.
okay. I know how to do it. Yeah.
Oh, okay. So this is for geometry. You can practice. But these questions are going to be hard. You see, initially they are going to be hard. Okay. So I'll tell you one easy way to come around that. Okay. Go to settings. Go to settings there in Alchemist itself. Okay, problem difficulty, make it to easy. Guys, you have been doing school-based math, right? School-based algebra books you've been doing. So there is no harm in setting it to easy or normal. If you put it in hard, you will run away. You don't do that. Got it? You don't have to. Go ahead with only these two settings. Easy, it will make your life easy. First practice that. That's what is required for speed-based test. Okay, then go to normal for conceptual understanding. These questions are going to take a lot of time, normal and hard. Easy, you can make a speed practice. Make sense? Okay, now where did we go? Alchemist. This is really nice, guys, though. Where did it go? Play. Now for us, see, the thing is, per this book, several of algebra 1, algebra itself covers several of your topics. Okay, absolute value function. See, For absolute value functions will be in here. I am thinking, see, absolute value functions are in here. They cover several algebra 2 topics in algebra itself. So the kids that are studying algebra 1, AOPS algebra 1 will study all of this. So they know how to solve absolute value function when they are studying algebra 1. So, but this is voluminous. This takes around 1 year plus. Easily it takes nicely. If we want to go through entirety, it takes 1 year, definitely full 1 year. So what I do, I start in January itself. Okay, so that by the end of that school year, right, by June, they are good with all of these topics. So when you go to absolute value, set new focus. You don't have to think, why am I solving algebra? Algebra 1, this is. In that book, it is like that. For you, you get to solve absolute value functions in algebra 2. And it's fine to go and set focus to that. Make sense? Okay. Any questions you have on this? This is one way. Okay. Here again, JSI, you, yeah, 1 minute. You are asking, right, JSI, solving two variable systems. Correct, JSI? So you
Yes,
see? Make sense?
Miss Priya, do you have any resources for like just normal SAT practice for like both English and math, or is it just this you have?
I can send the book. See, to get you started, I don't know where you are all with SAT math, but to get you started, right? Meaning you cannot be complacent. Who is this? I don't, oh yeah. Okay. You cannot be complacent stating, hey, auntie gave this book, I'll do only this book. If you will not be complacent, I don't mind sharing a book in the classroom. Can I share Panda book?
Okay.
That gives you the
Is
first
it the
basic.
Panda's writing guide?
Writing guide I don't have. You want the writing guide? I don't know. I can check and
No,
tell.
I have I know the site to the writing guide, yeah.
Panda math PDF.
Okay, if that's okay, could you share it?
Yeah, SAT math PDF I can share.
Okay. Thank you.
Yeah, meaning you can get started with that. Any problem you have questions on, please bring it to class.
Okay.
You know what? I'm also running a SAT. Meaning there's I don't do it for everybody though. Okay, but very rarely. Um, I can share some material for that matter, skill by skill. Meaning what I did was there are around several skills. Okay, there are around 19 skills I think totally, right, for SAT. So what we did was we did from skill 1 to 5 and then we are doing 16, 17, 18, 19. So those skills I
Okay.
have problems to solve. Did you see the question papers in College Board website?
Yeah, the College Board as question bank.
Yeah, College Board.
Cause that's where I got like questions from
Okay, I'll
past
show you.
SATs.
I'll show you. Meaning, try to do these guys. Try to download this. I'll show you. But I have it in the classroom. Which classroom was it?
It's because I'm studying for the PSAT 10 so I can get scholarships and stuff.
Yeah. For that, go ahead and see. This is for SAT.
Okay.
Okay, SAT, there are full-length practice tests available. This is from the College Board. Okay, what I do, see?
You
Test
go to
for,
Blue Book, right? And you just download and you do the practice test from there.
I have not bought the blue book, okay? In
You
College
don't
Board
need to
website,
buy it, Miss Priya. It's free.
it's free. Okay. So test 4 has full set SAT practice test, both reading and math is there, and answer explanations are there, and how they score you as well, it is in here.
Okay.
Okay, like that, there are around, I saw that there were 10 tests basically. So I just downloaded 4, 5, 6, 7 and had it in the classroom for kids to do. You got it?
Okay, if it's okay, could you share that?
Yeah, I can
Okay,
share that.
thank you.
Yeah, see, it is available on the College Board website, guys.
Yeah, I just don't know where to find it. I
No
have a
problem.
College Board account. I just don't know where to find it.
I see. No problem. I can share that. Okay, the only thing that I found it difficult was they did not have these all together. I don't know why in the world they would not have all of these together. That I don't know. Okay, I had to collect. Oh, where is that? Where is this? So separately. You got it? So
Okay.
I'll go ahead and share them. Any
Okay, thank
questions?
you.
You're going to bug me and ping me, right?
Yeah.
If I don't. Okay. Any questions? So these are areas where you can equip yourself, okay? And then you go here, go to resources, practice. And one another thing that I wanted to share is Math Bitch Notebook. Okay, I think this is an Algebra 1 class, right? But we are doing something else, okay? So you go here, this is also a very good thing. Whenever you have questions on a particular topic, right? on a particular topic, this teaches you so much, so very nicely.
We
Algebra.
can't see what you're showing. We only see the AOPS.
Oh, you know what? Oh, really? Sorry, guys. I was sharing the SAT full length practice test and this also you didn't see, huh?
Yeah, I didn't see you showing that.
Oh, sorry. Full length practice test. What I did find was in the College Board website, all the three were not together. Basically, answers, questions, and then we have scoring guide. Okay, they have 10 practice tests. Okay, I just downloaded, meaning it takes a lot of time to find out the details of where what is for each, right? So I just spent time on only 4. You got it? Any questions?
No, I'm good.
Okay, now, okay, AOPS Online is one website. The other website is this one. Okay, this one, the only problem with this one is it is nice and clean. You can follow these, see absolute value, go here and you can practice actually all of this, absolute value inequality. See, JSI, this is one place where you can practice if you're not sure as to what's going on. You get it?
Yes. Yes, ma'am.
Class recording is there and this will help you, really it will help you, but it will be very limited. You see, it won't solve complex problems. Make sense? Yeah, one big disadvantage of this is this particular website follows Common Core. Texas does not follow Common Core. Okay, so basically when you look at this website, see, this is compatible to NY next generation standards. Texas doesn't follow next generation math standards. Okay, so that's a big disadvantage when it comes to your school based curriculum. This will not cover exactly what your school covers, but it will help you on some topics where you really don't understand anything, struggling, but then you'll get the basics by going through this. Makes sense? And you go here, you can practice transformation, see? This will be very simple, okay, but that's what I'm saying. If you really want to practice the basics, if you're struggling completely, you don't understand anything, I feel like running away, so go here. You get it? And bring the topic to class. Any questions?
No.
Okay, now you wanted me to go to Google Classroom. Here you wanted to go to Algebra 2 classroom, right, ma? So what is that you want? Okay, Jessa, you can bring up your question, she can bring up her questions. Lasya and Srishti, did you have questions for your time for your? Thank you guys for adjusting with me for 20 minutes. It was so essential for me. I could not find an alternative. That's why I delayed the class by 20 minutes. Go ahead, Lasya.
We didn't have time to do much of it. I had a lot of homework this week. Sorry.
Emma, no problem at all. At the end of it, it has to be useful for you. Remember. Srishti, how about you?
Yeah, that's like the exact same thing with me, but like this week, like because I'm in algebra 2 right now, so like this week we were doing like we like started on like functions and all of that, and so and like absolute value and all that. So I like went back and I could like look at the stuff from before and like I used that to study, so it was helpful.
Okay, but so you did not get to this. That's fine, Emma. Okay, but make sure you follow it up sometime.
Yeah.
Okay. No,
I did like a couple questions, but I didn't get to finish it.
no problem. Jayasai, can you pick up one question? Can we try solving that?
Okay.
If it is a tier C question, in my language, it is the most difficult question. It is one of the most difficult question. I'll tell you some truths about how I come up with these. If it says tier C, it will be one of the harder ones. Yeah, do you want to pick out a problem?
I'm fine with any.
Any, okay.
Can I ask one?
Yeah, why not?
In the first question, like when I was looking over it, it was asking for like maximum, minimum, domain and range and like stuff like that. I don't know how to find it just from the like equation. I can find it in a graph, but like I don't.
No. The expectation is describe every transformation.
But it says C.
What?
On C it says state the verse.
Yeah. You have to draw the graph. That's the procedure, right? It won't
Oh,
ask you
so you want us to draw the graph? It's not
Let
from.
me see. Yeah.
Okay.
Definitely, I want you to draw the graph for these ones. Okay, I want to see.
Okay, then I thought you wanted it just like looking at the equation. I was supposed to find it.
No, how can you do that?
I don't know. I thought it was some way.
No, you have to draw. See, at your level, right? Drawing the graph and getting it is itself a big deal.
Okay.
See what I mean?
Yeah.
Yeah.
Then I can do it over the weekend because if it's like from the graph, I can solve this then.
This one is really hard. When I gave this, meaning when I added this to the Google Classroom itself, I thought there will be a bunch of people who come back with I don't know anything. That's fine, right? You should know how difficult are the questions. See, if you conceptually understand these questions, school is a breeze, but it is hard. Even 50% is okay for me. 50% of the
Okay.
questions you solve, it's enough. It will be a breeze at school.
Okay, I'll try my best to do it over the weekend.
Take your time, man. No hurry at all. Okay. So I can solve the first few. What big deal? First few should be easy. Oh, see. Actually, you know what? Okay. Tier B and tier C are only there. A is not there. I took it out. Okay. Now let's see. Now f of x will be equal to, okay, this is your parent function. Let's see. I don't know. Okay. I didn't solve by myself before the class. So let's see. 3 by 2 minus 3 by 2 f of 2 times x minus 4 plus 5. Okay.
Can I try describing the transformations?
Sure, why not? Go ahead.
So it would be a vertical stretch of, oh wait, no, it would be a reflection of over the x-axis. And then reflection, vertical stretch of 3 by 2. And then I think it's horizontal compression by 1 by 2. And then going to the right by 4. And then going up 5.
What do you guys think? Do you want to check against the answer? No, you got it. So now you're okay? 1 second, guys.
Okay.
Okay. Now you will be able to, one thing is, yes, verbal description is correct. Then you're going to graph it. And then you see what are they asking you. These are all difficult things. Rewrite g of x in simplified form. G of x equal to, in this format, you have to rewrite this. See, now you have 3 by 2 and 2, right? You're going to combine all of it and write it together. Make sense?
Yeah. It's just I didn't know how to, I only learned this like 2 days ago in school, so that's why I couldn't do it.
Okay, but yeah, see, okay, we have discussed only the verbal description. Okay, I've not taught you how to rewrite, but when you think about it, figure it out, it's very easy. Okay, when you have understood the graphing conceptually, how it works, it's not hard. Okay, now let's go over your answers. Okay, right 4, that's correct. Horizontal compression by half. Right 4, horizontal compression by half. Vertical stretch by 3 by 2, reflection on the x-axis, up 5. One thing what I hate about this answer is it's not in order. Please don't change the order. Always reflection, stretch compression, then translation. Please follow that order, okay? Otherwise, it's very confusing. It's okay to write it like this, but you cannot change the order of the translation. Always reflections come first, then stretch or compression, whether it is vertical or horizontal, you can change that. But then translation, okay? Now everything is right now here. Then what else? Okay, now how to bring it out? Basically, this was your parent function. But what happened here? Did you see 2 times x minus 4? It's like this, right? But again, this is absolute value of 2 is a 2, right? Meaning there's no change, right? So you can take it out and write it out as 2 times x minus 4. That's absolutely allowed. Got it? So what happens if you take it outside? Minus 3 by 2 times 2 f of x minus 4 plus 5, right? This and this gets cancelled. So minus 3 f of x minus 4, right? Absolute value of x minus 4 plus 5. Any questions?
I understand.
What is the vertex? See, the thing is, I want you to understand something here. Usually your absolute value functions are of the format a, right? A is your vertical stretch or compression. A is less than 0 means A is a negative value, means there is a reflection on the x-axis, right? Then you can have 1 by B x 1 by b, and inside that you have x minus h plus k. X minus h plus k. This is your general format of any absolute value function with all transformations. What are they? I can go ahead and explain this today. I mean, this format you need to know for every function. Even if I forget, you have to ask me, hey, what is the general format? Why? This A will involve vertical stretch or vertical compression. Vertical stretch means it's greater than 1. Vertical compression means it's less than 1. Then A also contains two other things. One is positive, one is negative value. Yes, Avyakt, 1 minute. Positive means what? Nothing. It's no reflection. But negative means it's a reflection on x-axis. Yes, Avyakt, tell me.
So if we're doing the generic rule, there's like a B value, would you write the reciprocal for it?
Yes, always.
So what are the times you would just like use 2 if like in case B is 2, what are the times you would only use 2?
Oh, okay. Okay. Okay, good question. Wait. Horizontal compression is okay. Yeah, okay, good question. Okay, Avyuk, think about this. He's asking a very nice question. Avyuk, this is your absolute value function, correct?
Yeah.
What is okay? You're talking to me about this too, right?
Yeah.
When should you use it as a 2? When you're asked for the factor, horizontal, is this a horizontal compression or a stretch? You tell me.
Compression.
You know that this is a horizontal compression by half, correct?
Yeah.
Horizontal compression means you're pushing the graph on this side, correct?
Yeah.
Horizontal compression means you're pushing the graph on this side. But what action do you do the same thing vertically? The graph will, so horizontal compression will make the graph thinner. You're with me?
Yeah.
In your vertical stretch or compression, which one will make your graph thinner?
The vertical stretch.
So horizontal compression by half is the same as vertical stretch by 2, correct?
Yeah.
That's what you're doing here. It was a horizontal compression when it was inside, it came out and became vertical stretch. You got it?
Yeah.
So anytime you bring it outside of the function, it's going to be like that because you're going to equate vertical compression and horizontal stretch and the vice versa.
Okay.
Makes sense? But sometimes you may be asked, see, when you write it here, right, you cannot say horizontal compression by 2. It's not a compression, first of all, then. You know that it's a compression and it is by half. That you know. So when they ask for the factor, right, value of B, then it is half. That's the only time you have a half there. You got it?
Yeah.
Yeah. So now do you understand the general formula? A means it tells about the stretch or compression vertical. Then positive or negative tells you reflection on x-axis. B tells you horizontal stretch or horizontal compression. Horizontal compression means this the opposite, greater than 1 and less than 1. Positive means nothing. Negative means reflection on y-axis. Okay. And here h comma k is your vertex. H comma k is your vertex. Okay. What is your axis of symmetry? H comma k is your vertex means wherever the absolute value, this is h comma k. So what will be the axis of symmetry?
X equals H.
X equal to h. That's it. That's what they're asking. See, vertex is 4 comma 5. Axis of symmetry is 4. Now, once you plot the graph, you will be able to write the domain and range without me. You don't need help on that. Do you guys get it, guys? See, these questions, absolutely I'm open if you bring it back and ask, because these are difficult, but these gets you the conceptual understanding of the entire concept. Done, guys? Did you understand well, Ma?
Yeah, this is really helpful.
JSI, did you get that?
Yes, ma'am.
Okay, where shall we go and how shall I help? Okay. We can review system of equations, even we can help. I can go over 1 or 2 questions and make you, I'll see.
Could you do number 7?
Yeah, 30 questions in 5 minutes will happen, JSI, only when you work through 100, 200 questions. You get it, huh?
Yeah.
It takes a very long time and you should be able to identify parallel lines quickly. You get it? Meaning, when there is no solution and infinite solution, you should be able to identify just like that. Then only 30 questions, 5 minutes will work.
Mm-hmm.
Makes sense, huh?
Yes, ma'am.
Yeah. Can I erase this, guys? I've written all over the place. I hope you understood. Can I delete it? Can I delete it?
Yeah.
Okay. Then what else, guys? Next one. 7th one. I don't want to see the answers before we do. Well, let's see what is this. It's a tier C question. Good. Okay, how about this? F of x equal to x plus 2 the whole square minus 5. What is that? Oh, okay. G of x, they have given minus 2 plus square root of x plus 5. Okay. Use both composition. Oh, guys. Actually, I covered domain of composite function. Okay, let's see. Use both composition with appropriate domain restrictions to determine. Okay, this one is a complicated question. Okay. Let me bring this to the notepad. Okay. I don't know how many of you will remember this. We did it in summer in both the classes. I don't know, but we did the same, not the same question, but one full class we wasted on this. Finding the domain of composite functions. Finding the domain of composite functions is a little difficult, guys. Wait, let me see. I need to bring that again here. 1 minute, wait. Give me a minute. I remember doing several problems on this in class. Domain of composite functions we did. Shri, 1 second, guys. Prisha, are you following? Did you have time to do the homework, ma, Prisha?
I did a little bit, but I had a lot of work, so I didn't get to fully complete it and submit it.
Okay. I brought up my set of problems that we did in summer in one of the classes. Ananya was there in that class. They were all asking so many questions. I think it was in this class, Friday class. I don't know where is Ananya. Ananya was there, and I remember a couple of you were going on asking questions in that class. I remember, but I can check later which was the class. Okay, but before I move on, right? Wait, I want you to understand how to find domain of composite functions. Let me see. 1 second, guys. Okay. Okay. Let's work this out now. Okay. Composite functions, you need to know how to find the domain. Okay. Problem is, guys, earlier, right, pre-calc used to have this particular topic. Okay. After that, when they went to AP pre-calc, all this has been removed and it's such nice concepts that you need to know. Okay, wait, let me see whether I can bring up. Okay. One second, guys. let's find out a simple one. Okay. 1 by, okay, we are going to find out for this function. See, but these are rational functions. You have not covered rational functions. First, let's consider a simple function, 1 by x minus 2. Okay. What is the other function? One second, guys. I want to give you a couple of problems properly. I don't know. 1 second, guys. I have to get the problem set first. Okay. I want to give you some simple functions first, then find it, then we'll see. Sorry, guys, I was not prepared to get you these immediately. Wait, functions were you need to find the composition functions. Okay, inverse function. Then we did composite functions. Okay, so we need to find the domain of composite functions. I don't, yeah, composite function domain. Yeah, theory practice. Yes. Okay. Okay, let's do this one. F of x equal to square root of x. This is a very simple one to start with. Okay, we'll go with rational functions all later. Okay, it's a very simple one. We are going to go to composite functions. Okay, let me go through that. How to find the domain of composite functions. That's what we are going to do. F of x. Avyuk, you were present in the class, right? Avyuk, when we discussed domain of composite function. Huh?
Yeah.
Yeah, that's what I think. You and Ananya were going on asking questions. Remember?
Yeah.
Yeah. So f of x is equal to square root of x, g of x equal to 2x minus 3. What is f of g of x? What is f of g of x? It's a composition composition or whatever, composite function. Basically, this is a composite function. This can be written as f of g of x. Correct, guys? How do you find it? First, g of x is here, right? G of x is there. So I'm going to find out f of 2x minus 3. That means what? Instead of x, I'm going to pass in 2x minus 3. That is square root of 2x minus 3. Any questions, guys? This is composite functions, right? You know how to find composition functions, right? Okay. Now, when you find the domain of the composite function, right? The main thing, first rule is x must be in the domain of G. X must be in the domain of G. Find out the domain of G, okay? Make sure x is present in the domain of G, okay? Then G of x must be in the domain of F. Make sense? Why are we trying to make these two conditions? One is x should be in the domain of G. In G's domain, x should be an input. Okay. Then we found out the output of g of x, right? That you're going to feed it as the input to f of x. So g of x is your independent value here. G of x should be in the domain of f. Does that make sense? X should be in the domain of G. G of x should be in the domain of f. Let's find out one problem, okay? Now, let's do one problem, you'll really understand. Okay. When you identify domains, what can't be there, what can be there? If it's a denominator, it cannot be equal to 0. If anything is within the square root, it has to be greater than or equal to 0. These are common things that you generally make sure they happen. Okay. Okay. Can we move on? Can we move on? I'll do one problem. We'll do this one. How about this? 1 by f of x, we'll come back here as well to find the domain. 1 by x plus 2, g of x equal to 1 by x minus 3. Let's say they've given these two functions. Okay, what is function composition? Basically, you are going to find out f of g of x. So what will you do? 1 by x minus 3 plus 2. Any questions, guys? Any questions on that? Finding function composition.
No, I understand. But is
Okay.
that the answer? There's no like, you don't simplify it or
No,
anything?
you need to simplify that. You can do it, I'm thinking.
Okay, so once you simplify it, that's the answer?
Yeah, once you simplify, that's the answer.
Okay.
Okay, now the thing is, how are we going to find the domain? First of all, in the composite function, the denominator can't be equal to 0. You know that, right, ma? This cannot be equal to 0. Make sense? 1 by x minus 3 cannot be equal to a minus 2. Does that make sense?
Yeah.
So how to evaluate this? What is the restriction you'll come up with?
It has to be greater than minus 2.
Wait, let's see. Yeah. So how will we deal with this? So I will write it down here. 1 cannot be equal to minus 2x plus 6. Correct? Right? So x cannot be equal to plus 5 by 2. Make sense?
How did you do that?
Why? 1 cannot be equal to minus 2x plus 6. Subtract 5 on both sides.
Oh, okay.
Subtract 6 on both sides. So you get minus 5 is not equal to minus 2x. Divide by minus 1 on both sides. 5 cannot be equal to 2x. X cannot be equal to 5 by 2.
Okay.
That is the biggest restriction. Directly on the composite function, you will see that the denominator is never a 0. Okay? Make sense?
Yeah.
Okay. Once you identify that, right? What else? What are the other restrictions? Yeah, you know what? See this here, right? This one. In this one, g of x domain you need to understand, right? What is g of x domain's restriction? X must be in the domain of g. What is the domain of g? Domain. See the g of x function. What is its domain? X can't be equal to 3, correct? So that is an important restriction too. So first you identify the domain of g. What are the restrictions you need to see? Okay, our composite functions x should be in the domain of g. So first thing is x can't be equal to a 3, right? And after that, what you need to verify? G of x must be in the domain of f. G of x must be in the domain of f. What is the domain of f? So here for the overall function, what was the restriction? The restriction was x not equal to 5 by 2. For the domain of g, what was the restriction? X not equal to 3. So combine both the restrictions, x is not equal to 3 or 5 by 2. Make sense? Composite functions domain is a little complicated. Can I move on?
Yeah, it makes sense.
Okay, how about I can get more. I don't want to keep on doing this. Let's see. Let's try this one. Okay, inner function, outer function I want to do. Okay. Okay. Okay, how about this? Let's say we have these two functions, f of x equal to square root of x plus 1, g of x equal to 1 by x minus 2. Okay, now I want to find out f of g of x. Can you find that out, guys, so that we revise composition today itself? Why keep doing, meaning why keep me keep doing everything?
We need to figure out if they're inverses.
Illama, you just need to find out f of g of x.
Oh,
Is there a way to simplify it or not?
Yeah, you will get a simplified value, ma.
Okay.
You'll get a something simplified within the square root.
I'm not sure how to do that.
Why, ma? Instead of x, you substitute 1 by x minus 2 and take LCM.
Okay.
Get it, guys?
I mean, I got like an answer, but I'm not sure if it's like correct or not. Because it seems odd, like the square
What
root.
is it? Yeah, shout out what is the answer?
I got like square root of 0, which is basically 0.
Why, ma? See, f of g of x means what? It's a composition, right? G of x is this. You're going to feed that. F of 1 by x minus 2 you're going to find, right? So go to the f of x function. Instead of x, you're going to plug in 1 by x minus 2, correct?
Yeah.
1 by x minus 2 plus 1, correct?
Mm-hmm.
Now you're going to bring both the denominator to x minus 2, right? So multiply by x minus 2, divide by x minus 2 on the second one, right? So you get x minus 2 as your denominator. Your numerator will be 1 plus x minus 2. So this can be rewritten as x minus 1 by x minus 2. Yes, that's right, Abhyut. JSI, I think you were not present for this class. F of g of x will be equal to square root of x minus 1 by x minus 2.
Yeah, I understand my mistake. I put a negative 1 instead of a positive 1.
No problem. As long as you understand, I'm pretty happy.
Yeah.
Okay, now how to find out the domain? As I said, right, the first thing what you need to do is you have to make sure g of x domain you need to find out. That's the inner function, right? First go ahead and find the domain. What can't be the domain of this? It's all real numbers, but there is some number x can't be.
2.
Because 2, good job. So x minus 2, denominator can't be 0, I told you, right? X can't be equal to 2. This is the first restriction you'll obtain. So because, see, we are going to feed x as the input. You need to know x is not equal to 2. That's an important restriction, okay? Second thing, look at this function, okay? What is the domain restriction on this? Domain restriction means what is the restriction on x for that function? What does it say? If I feed in anything as input, what is the restriction on this?
X has to be greater than minus 2, because otherwise it'll be a negative number.
X has to be greater than?
Minus 2, negative 2.
Sorry, ma, JSI. X has to be greater than what?
Negative 2.
Forget this. You're not even considering your inner function. I'm just asking, given this function, what is the domain restriction, input restriction?
Yeah, it would be negative 2, because if we did negative 2 plus 1, it would be negative
X
1.
plus 1 should be greater than or equal to 0. Did you do this? Why negative 2?
Because we can have a square root of 0, right?
Yeah, you can have square root of 0. So x is greater than or equal to negative 1, right?
I just did greater than 2 because like 2 is like the lower domain, right? Because
No, that's
I
what
didn't
I'm
do
saying.
like
Minus 1 is a lower domain, right? Because if you substitute minus 1, then it is a 0. Then you substitute minus 0.9, still that works because that becomes a positive value. So whatever is inside your square root should be greater than or equal to 0. That is the restriction, right?
mm-hmm.
Does it make sense?
Yeah.
Okay, so from here, what do we understand? Whatever input we are passing to f of x has to be greater than or equal to 1. Are you all with me? What input I'm going to pass? What is the input I'm going to pass when I'm finding the composition? G of x. Do you see, guys? So what does that tell you? This x is no longer x in the composite function. The composite function, you're feeding the input as g of x. So 1 by x minus 2, which is g of x, should be greater than or equal to minus 1. Does that make sense?
Yeah, and then you just solve for x.
Yeah. Does that make sense?
Yeah.
It's a little messy, right? So x can't be equal to 2 and x is greater than or equal to 1. So how do you write that? X is greater than or equal to 1 and x can't be equal to 2.
Miss Priya,
Yeah.
I'm kind of confused. You said it can't be be equal to -1, right?
Which, yeah, the input, this is the input, ma. When you think about it, input x plus 1 has to be greater than or equal to 0. When you consider x as the input to f of x, input plus 1 should be greater than or equal to 0. As a result, x is greater than or equal to minus 1. Am I making sense? When you find out your composite function, your input is not x. What is your input?
It's f of g of x.
G of x is your input.
Oh.
G
Oh,
of
yeah.
x is your input, right?
Yeah.
Yeah. So g of x is your input.
Which is 1 over x minus 2.
Wait. Let's do it again. So what is x plus 1 is greater than or equal to 0? Let's do it that way. Okay. From here, we'll do it again. X plus 1 is
What
greater than.
confuses me is that it says x is greater than or equal to -1. That's what confuses me.
Yeah,
And you,
okay, that's what I didn't go there. Okay. This you understood, right? Meaning whatever
yeah,
input you feed to f of x should be greater than or equal to 0. Right? In your composite function, what is your x value?
g of
1
x.
by x minus 2. Are you with me?
Yeah.
Huh?
Yeah.
So as a result, 1 plus x minus 2 by x minus 2 is greater than or equal to 0. Are you with me? X minus 1 by x minus 2 is greater than or equal to 0. Are you with me? Makes sense, huh? So x is not equal to 2 is already covered here. X is not equal to 2. And then what?
Sorry, Miss Priya, can you explain that again?
This one you did not get, ma?
Yeah, sorry, I couldn't understand. Can you explain again?
Okay. Okay. You know what? Otherwise, I'm going to skip the domain of composite functions for now. Okay. What I'm saying is the
Yeah.
input that you're feeding to f of x should be greater
Yeah.
than or equal to 0 if x is
Yeah.
your input to f of x. But in a composite
Yeah.
function, g of x is your input to f
F of
function.
x.
Okay.
Yeah.
As a result, this changes to g of x, which is 1 by x
Yeah.
minus 2. So 1 by
Yeah.
x minus 2 plus 1 should be greater than or equal to 0.
Okay.
When you simplify that by taking LCM, meaning this does not have an x minus 2 denominator, right? So multiply by x minus 2, divide by x minus 2 for you to have a common denominator. In that case, it becomes 1 plus x minus 2 by x minus 2, which is x minus 1 by x minus 2 is greater than or equal to 0.
Okay.
Make sense?
Yeah.
Okay. Here what happens? X is, what is the restriction here? X is greater than or equal to 1. So x can be equal to 1. X is greater than or equal to 1. X is not equal to 2. Make sense?
Yeah.
Okay. Combining all these restrictions, you have to you have to write out the domain of f of g of x. Why don't we postpone? Meaning, if it is too hard, I don't think school is going to cover the domain of composite functions, I feel, but I don't know. Okay. So let's see. When you combine all of this, what do you get? For this one, for the f of g of x function, this is your f of g of x function, right? How do you write out the domain? You can write out clearly. 1 is very clear. It can't be equal to 2. Okay. So 2 to infinity is a part of the domain. Okay. What else can be part of the domain? X minus 1 is greater than or equal to 0. X is not equal to 2 is okay. And then what else do we have? 1 second, guys. Give me a minute. Yeah. Yeah. See, for here, yeah, here you are having, you have to test this out. Okay, x is greater, you are getting x equal to 1 and x equal to 2 as values that need to be checked. So minus infinity to 1 to 2 to infinity. You have to split this into different intervals. Put some values into this function and see what makes it a negative sign inside. Whatever makes it a negative sign can't be included. So when you substitute a number between minus infinity to 1, let's say minus 2, if you put it in here, right, it'll be a minus 3 and a minus 4. So it becomes positive. Do you see? But when you put a 1, it becomes 0. So minus infinity to 1 is working. Do you see? But after 1, if you put a 1.5, shall we try by putting a 1.5? Then it will be a 0.5 numerator. Denominator will be 1.5, 1.5 minus 1 positive, then 1.5 minus 2. See, that gets you a negative value. After 1, right, if it is greater than 1 or equal to 1, equal to 1 is working. So, minus infinity to 1 is working. It's in the domain. Minus infinity to 1 is working, right? 1 also is working. That's what I see. 2 is not working. It can't be 2. 2 cannot be included. So minus infinity to 1. And then between 1 and 2, nothing is working. Everything results in a negative number here. Okay, 2 also can't be included. But 3 works. 3 minus 1 is a 2. 3 minus 2 is a 1. So it becomes a positive inside the square root. So the domain, per the domain restrictions, the only possible values are minus infinity to 1. 1 is included and 2 to infinity. This is how you have to write the domain of composite functions. This is a little tricky problem. You won't get this now. We are only covering absolute value functions, but then let's go back. Let's go back and solve what we had, right? See, half of the class will go if we discuss anything extra like this. Okay, let's do this. F of x equal to x plus 2 the whole square minus 5. G of x equal to minus 2 plus square root of x plus 5. Now, with proper domain restrictions to determine whether G equal to, they're asking whether G is your F inverse. How do you find the inverse, ma? F of x equal to x plus 2 the whole square minus 5, right? I can write this out as, how do you find inverses? We are just revising inverses and composition. So here it would be x will be equal to y plus 2 the whole square minus 5. Then how? X plus 5 will be equal to y plus 2 the whole square. Then take square root on both sides. Y plus 2 will be equal to square root of x plus 5. Right? So y will be equal to minus 2 plus square root of x plus 5. Do you see it, guys? That is your f inverse of x. I am saying use both composition. Yeah, this is correct. Make sense? Okay, now how do you write the domain of f of g of x? First, you need to find the domain of g of x. With this, we'll close the class, okay? Okay, how to find out the domain of f of g of x? First, we need to find the domain of g of x. What is the domain of g of x? Meaning, what is the restriction on the domain of g of x? X plus 5 is greater than or equal to 0. X is greater than or equal to minus 5. Any questions still here? Okay, but first let me check whether our answer for this is right in our homework. I'm going to go to the answer. I'm going to check for the answers once. This is question number 7, right? Question number 7. The inverse function is correct. Let's see. G of... what did we have as the inverse function? Y will be equal to... yeah, f of g of... we found out the inverse, right, first. Yeah, g equal to f inverse is correct. Can we try the next one? Let's see. Okay, now we have to find the domain, right? So first of all, I found the domain restriction on g of x. What is the domain? Domain restriction means what the input can't be. The input can't be, the input has to be greater than or equal to minus 5 for g of x, right? What is the domain restriction on the input fed to the original function? What is the domain restriction here? All real numbers, right? Here, x can be any number because it's squared and then a minus 5. So, what can be the domain restriction on that? I don't see any domain restriction at all because it's a quadratic function and whatever input you give, it's squared. Now, however, in my composite function, x is not my input, g of x is my input, right? So, as such, any input can be fed to f. There is no restrictions. However, the original g of x had this restriction. So, what has to be the domain of this? The domain of this has to oblige this domain restriction and the domain restriction on this function as well. Okay. Here x is greater than or equal to 5 means 5 comma infinity. Minus 5 has a square bracket infinity. This is how you need to calculate. For calculating the domain of composite functions, what is very important is first understand what, the domain restriction on g of x. This is the first one. Then understand the input fed to f. What is the domain? What is the restriction for the input fed to f? Also remember, we are not going to feed x as the input. We are going to feed g of x as the input. So whatever restriction you get from there, right, has to be applied for g of x. So you have to say that this one, whatever x can't be, this entire thing can't be that value. If you apply that and find out more restrictions, you have to combine this with that and find out the final restriction. Am I making sense? JSI, did you follow?
Yes, ma'am.
Did you, okay, another thing, maybe I can take 1 or 2 more minutes of your time. This one we did, right? Like that you need to find for g of f of x.
Okay.
It's the other way. Okay, now I want to tell you something. This one, I didn't have a closure. Last time when I discussed with you and others, right? I didn't have a closure of, we did inverses separately, composition separately. So one thing what you need to understand is, see here, for this function itself we'll take. We found out that g of x was the inverse function, right? G of x was the inverse of f of x. Here we did find out, right? What I didn't tell you was, composition, this particular step I didn't tell you. Composition of a function and its inverse is x. We'll finish with this, please. Composition of a function and its inverse means f of x is our function. Right? Composition of a function and its inverse. F inverse of f of x or f of f inverse of x. Both will be equal to x. What does that mean? Let's try this because these two are inverse functions, right? Let's try that. F of g of x, I'm going to find for this one. F of g of x. That means what? In f, right? In f of x function, I'm going to substitute g of x. Instead of x, I'm going to substitute g of x. Minus 2 plus square root of x plus 5 plus 2 the whole square minus 5. Does that make sense? In this, instead of x, I'm substituting the whole, this one. So this and this will get cancelled. Square root of x plus 5 the whole square minus 5. What is square root of x plus 5 the whole square? That is x plus 5. X plus 5 minus 5. See, f of g of x is becoming x. So whenever you compose a function and its inverse, here g of x is the inverse of f of x. So this is nothing but f of f inverse of x. So that is equal to x means whatever functions you consider, the two functions are inverse, one function and its inverse. So f of f inverse of x equal to x. One another thing I want to prove here, the other one, f inverse of f of x. What is that? G of f of x. Let's try that. That should also be equal to x. Basically, I don't know. G of x is what? Minus 2 plus square root of x plus 5. But instead of x, I'm going to substitute this one. So instead of this, x plus 2 the whole square minus 5 plus 5 within square root. Right? What happens? 5 gone. X plus 2 the whole square when square rooted will be x plus 2 minus 2 plus. This and this gets cancelled. X. Do you see? So here f inverse of f of x is also equal to x. It's a universal law. Composition of a function and its inverse is always equal to x. Make sense? Will this help you to work out a little bit more, guys?
Yeah.
At least 5 problems you do. That's enough for me in that homework. 5 to 7
Okay.
problems you do. But one type of each. In each section you do two problems. You got
Okay.
it?
Yeah.
Okay, guys, I'll stop here. I took more time. Algebra 2 is always like this. It's always rushed up because you have a lot to cover. Okay? Yeah. Yeah. If the finding the domain of composite function is difficult, please bring back the questions. We'll do it together.
Okay.
Okay. Bye, guys. We'll do
Bye,
it
Miss
next.
Priya.
Bye, ma. JSI, I can talk to you. Avyut, you said you'll wait. Yes. JSI, go ahead. What's your question, ma?
Ma'am, there was really nothing else. I just wanted to say thank you for the help and that.
Oh, no worries at all. But will you try and come back and ask? I'll help you more, I'm saying.
Yeah, sure. I'll do it. I'll
See,
like
in your class, I don't have a class afterwards as well. So if you bring back questions and if I'm even not able to do everything and still you have questions, I'll solve and send. Go through it. Okay?
Okay.
Okay. And for your system of equations in 5 minutes, right? I'm just thinking what can help you. You have to solve a lot of problems. Do you have a lot of
Ma'am,
problems?
it wasn't really 5 minutes. The systems of equations was like a 12-minute test with 8 questions. It was only the A equals 1 where we had 5 minutes one.
Oh, factoring. Ah.
Yeah.
Ma, please solve more. Do you have resources? Do you have enough
They
problems?
said they'll give us like review packets for the unit test. So I'm gonna practice that. And then my dad is printing some papers. And I'm gonna try and like finish up all of them and practice it timed over the weekend with my dad. And then we'll see what happens on Monday and Tuesday.
Okay, and for your factoring, right, you can do here as well, meaning this is quadratics, right? Go down in algebra, here, see, completing squares, here, wait. Factoring, see, this one you need to complete till 100. You see, factoring general quadratics, when you solve more problems, harder problems, set it as easy, normal, solve every problem, you'll be fine.
Ma'am, I looked at those questions while you were like discussing them, like when you were discussing through this like website. But the thing is, they asked us for perfect square trinomials to be exact.
Means, can you show me one example? You have an example?
Yeah, I do. Give me 1 second. I'll get my mom's phone. So
Oh,
like
yeah, I know what you're asking. Perfect square, show me, I'll help you there. It's easy to find them.
they gave us like this was on the practice test that they gave us. So one of the questions was like x squared minus 3x minus 40, and they asked us to find the two.
1 second, 1 second. Go ahead.
X squared minus 3x minus 40.
Minus 4?
40. 40.
40, yeah?
Yeah.
Okay.
Like
Okay.
I'm able to do them like pretty quickly, but like whatever I do sometimes I mess up on the symbols or like this. And I wanted to know if there was like a faster way of getting all the symbols right and stuff. Or unfactorable questions.
1 second. Jay, how did you find the factors of this one question?
I'll just like quickly go through the factors of 40 and then I just do like
Correct.
find
See, that is the fastest. Anna, do you know, meaning after that, do you know, meaning you're confused with the factors, right? It can be
yeah.
this or it can be, this is where you're getting confused, right, JSI?
Uh-huh.
But do you know that this one, B by 2, B by, you know Vieta's formulas? You've heard of Vieta's formulas?
No, not really.
Okay, see, that can help you quickly to identify whether your signs are correct or not. Okay, Vieta, sum of roots. Okay, sum of the roots of a quadratic function, right? Minus b by a and c by a. See, minus b is there. 3 should be the sum of these two numbers. You know that?
Mm-hmm.
Minus b, if this is 1, right? Minus b should be the sum of the roots. Minus b is what? 3 here, right?
3.
So the answer is this. You see what I mean, huh?
Uh-huh.
So if you have, that's the easiest way for you not to worry about the signs of the functions. Minus b by a is the sum of the roots.
Ma'am, but if we do minus 5 plus 8, wouldn't it result in 3?
Minus 5 plus 8 will result in 3. Yes.
But we have a negative 3 over here though.
Lima, what is the answer to this one? This is the answer, right?
The answer they gave us was x minus 8 and x plus 5.
Correct. The factors are x equal to 8 and x equal to minus 5. So when you write it in the form, it will be x plus 5 and x minus 8.
Oh, so we flip the signs?
You're not okay. See, these are factors. Factors means x value. Wherever, when you draw it as a graph, right? At 8 and minus 5, you're going to have the zeros. Okay. When you write it in the linear form, right? You will see when x is equal to 8, how will you write it as an equation? Meaning, how will you write it as equal to 0 equation? Subtract it, x minus 8 will be equal to 0. You get it?
Uh-huh.
So you will write this out as x minus 8 and x equal to minus 5 means what do you do? X plus 5 will be equal to 0. So that you write it here.
Oh, okay.
Make sense?
Yes, ma'am.
Yeah. So here it is minus 3 now. Minus b, minus of whatever is in here is the sum of the roots.
Uh-huh.
That they don't teach it in your school-based math. They teach it in competitive math. A product of the roots. Product of the roots should be C. Product of the roots is minus 40 here, right? So 8 and minus 5 accounts to minus 40.
Okay.
Make sense?
Yeah.
So it's always written in the format x minus r, x minus s. R and s are roots. Yes, JSI. But please look at Vieta's formulas. Vieta's sum of roots and product of roots.
Ma'am, how do we spell that?
VIETA. That can really help you quickly iron out without the problem of.
Ma'am, one last thing. Is there any way to find unfactorable function like trinomials quickly?
With practice.
Practice?
Yes. With practice is the only way out.
Okay.
Yeah, that's the only way out.
Okay.
Okay, yeah.
Thank you, ma'am. Bye.
Sorry, Avyukta, I made you wait. What was your question?